Well, I sincerely appreciate you all joining us this evening. I have the distinct pleasure of getting to work with and having gotten to know over many years of work and research and study and being the student of both Peter Del Tredici and spent a fair amount of time working with Ethan Dropkin. And I'll introduce them in a minute. But what I'd like to do also is just speak more broadly and as a kind of a mechanism of framing, if you will, for why we're talking and what we're talking about this evening. Before we get to that, though, I would like to say thank you to a couple of very important people. First and foremost are the 4 students who gave up an immense amount of their own time and creative power to think, draw, question, and learn from folks like Ethan, and to contribute on a fundamental level to helping assemble the program that you're seeing this evening. So thank you to Alex, Agnes, Edvi, and Veronica for all of your efforts and your beautiful drawings. You'll see a number of them this evening. Also, sincere thank you to the Howland family. Obviously, not just your gift, but the contribution of your time. What you'll see in the following slides is actually just a slight reflection on what I learned in getting to speak with you and see some of the works and drawings of Mr. Howland's over the course of his career. And those have really inspired the thematics for tonight, and I'll try to give you a rationale for why that is in fact the case. So I'd like to start with a couple images from Mr. Howland's collection. The first is an image of Assateague Island and its vicinity, and the other is Wallops. Both are planning documents that were developed by Mr. Howland in relationship to his time here, both at the University of Virginia, but also his work with the Department of the Interior. And I know when we think about the 1960s and 70s and a lot of the large-scale planning works, we tend to think about them as large, zoomed-out studies, right, that looked at a lot of the connectivity and large-scale ecological systems. And we also see this in the work in relationship to him and his vision in conjunction with the Environmental Sciences Department here at the University of Virginia, and the commissioning of one of the first Landsat satellites to study coastal change and coastal dynamics in a national park, to the best of my knowledge. And we have those documents here, and great thanks to the Howland family for sharing them. However, the reason why we're talking about rural landscapes, we're talking about scales of infrastructure, but we're also talking with 2 plant experts tonight, is that we can't fundamentally understand and think about how to effectively plan and design at those scales with dynamic ecological systems without a fundamental understanding at the real scale at which a plant grows, how it changes, how it undergoes change, and in a better way of saying this that Peter will talk about in specific is how a plant informs us about its environment and the changes that are happening, as well as how it in fact creates its own environment. And as a dynamic system, plants can do things that really no other life form on Earth can. We saw this, or at least I had the privilege of seeing this in Mr. Howland's drawings and work, is that for every image of a large-scale plan, you see the Assateague Island plan in the base, there were 4 other sketches, hand drawings, of scenes from those sites. He had clearly a very fundamental understanding of the cultural characteristics, meaning the image of the horse wasn't necessarily, and as far as I can understand with reading, it wasn't necessarily simply talking about it existing as a wild animal, but rather that it had a dynamic. He drew it eating, right? It had a dynamic relationship that caused or encouraged an environmental condition to evolve. And so the plan was not inextricably linked, or could not therefore be separated, rather, from the dynamics of the things that live there and the ranges in which they lived. And we saw this over and over again in his drawings. So in every set of drawings, page to page to page, in these planning documents, you would find beautiful notations about ideas in cross-sectional form, about the way in which cultural relationships were formed with living organisms, with plants in particular, and their relationship to large-scale moves and a vision in the 60s and 70s that had yet to really be laid as a foundation for how we would do this work. And as I mentioned before, for every one of those zoomed-in drawings, there was yet another pullback to science. There again was this extreme value placed on study and study and study on really multiple avenues, right? So it wasn't just purely coastal dynamics and sediment movement. It was always paired with another set of dynamics and change. But the innovation wasn't just limited to the physical world. It was also tied extremely tightly to an understanding, and you'll see, I apologize, the scan is a little bit squirrely, but you'll see a title called Legislative History. And the image on the right, paired to that, is a silt fence, right? It's a method of changing dune formation by slowing down the movement of sediment in the wind. And those two, I believe, were very intelligently put together as a logic for suggesting that those two things were also bound. They were bound and fundamentally tied in a way that the planning document needed to reflect that work. And so ultimately that culminates with a number of documents, and you'll see these. He not only worked in the Assateague and Chincoteague and Wallops Island chain, he also worked further south in the North Carolina coast, and also out west. So he touched many places in the United States with his work, but it again brings back to a point of reflection. Why shrublands, why living fences, and why dynamics of rural landscapes in particular is not to suggest that they are somehow not public in nature as well, but that the role of infrastructure that sits behind this is a cultural project for landscape architects. And we know this through the work of people like Brian Davis as well, who talk extensively about how fundamental design problems and approaches to those are immense opportunities to engage and re-engage, allowing people to see themselves in the works of infrastructure. And how we do that best, in my opinion, and why I've invited Ethan and Peter here tonight to join us, is through the details of the work. Those are the things most relatable to humans. Those are the things that we can intervene with most directly, and those are therefore the things that encourage and guide design inspiration in really every scale of our work. And so to the measure of the evening, which is this question of shrublands and living fences. And I'd like to start with this from Mount Vernon, a quote from George Washington that fundamentally gets at an idea which I found really curious in reading and studying a history of this, which actually turns out to be an immense frustration over the course of 16 years where he was trying to convince all his farm managers to do this. He wanted them to make the fences out of living material. He wanted them to grow and change. He wanted them to be made out of several different species. He ultimately settled on what you'll see here, Gladitia tricanthos. However, they refused to do it. So they tried and tried and tried to get this to land, and they decided fundamentally it was too much work. And so the European project that you oftentimes see showing up in many of the kind of bucolic visions of countrysides throughout European countries does not necessarily land here in the same form, though it was certainly attempted. By 1805, we see books on volumes and volumes and volumes. This book is from, as I mentioned, 1805. There was a reissue in 1807 and again in 1815, 1,000 pages on farmsteading, and an entire chapter dedicated to simply the idea of living fences, the manipulation of plants, and also in this case, what I found extremely exciting as a landscape architect, a holistic vision that looked at the role of land and earth form, plants both dormant and active, being shaped and guided and manipulated, but also in some ways that suggest an understanding of scale had fundamentally changed. Whereas when we look at Washington and we look at some of the other folks who had large estates with many, many people, and the enslaved being a big portion of that, by the mid-1800s and shifting outward, we see people taking on or thinking about the scale very differently. And to the point where we get to what is now fast forwarding contemporary day, and we'll go back in time for a moment, this, what I find to be a beautiful ambiance created by what was at one point a living fence from McClure. This species known, or at least was quoted as the plant to stop an elephant, because of both the thorns it creates, but also the wood entanglement. You can see both in its living form, right, which is that area kind of at or below the eye line, or its fence form, excuse me, and also what it had become once we stopped intervening. What I found more fascinating about it, however, was tracking down this historic photo of the same site in which we see how that living fence was brought to bear. The idea of how it starts and how it evolves and how management is a fundamental part of that, and even how the lack of certainty associated with having one fence line constructed in standard approach and the other right next door to it, experimental in nature, attempting to create this beautiful layering that serves as both habitat construction, defense and an edge, and fundamentally its own, just to go back to this image, its own form, its own space, I found to be a beautiful, elegant, and interesting, and really compelling part of what we can do as landscape architects. But we need to see the opportunity as something a little bit different than we did in the mid to late 1800s. In the case of the quote you'll see here, really the summation in my mind is this. It was fascinating, capable at scale, but ultimately gave way to a cheaper, more efficient, available technology. And barbed wire, while potentially as wonderful as it is, cut short the opportunity that we had seen throughout the Midwest at one point in time, where McClure was readily planted, as you'll see in this quote, but also in places like Virginia, where immense opportunity still exists to think about ways in which experimentation and design can allow the public to re-engage questions and learn with and around us as we figure out how to maximize our ability to create habitat that is not restoration, but is in fact new, novel insertions into an existing, highly manipulated system such as a farm field. And I think when we stop seeing things necessarily not as something that can be cast aside entirely, but always thinking about the baseline conditions, what exists and why it exists there, and how those forces and factors feed to make the space look the way it does, I think we see our role as landscape architects truly maximized. And the reason I say that in front of this image in particular is that while this was a sterling example of what it was for the country to come together in a moment in time of great difficulty, the Dust Bowl, the Great Depression, we were facing a pretty uphill climb. I think most people would agree with that assessment. However, it was the idea of creating a shelter belt to fundamentally change the ecology of the Great Plains, which, if you've ever been to any of those states, is an unfathomable scale at which we were attempting to alter, was a great social project. But the quote paired on the left suggests another really important part of the consideration of this, which is, should we? Should we think about plants and the role of plants as something that can be made and remade exclusively, or should we think about what this quote suggests from Rosetta Elkin, survivability, functionality, a dialogue between an environmental system and how we think about it as designers? So rather than a capital project, an adaptive management technique. And there's plenty of debate about these things, and where I'll start to introduce one of our speakers tonight, Peter, is around exactly that. Yes, plants can do this, right? So as the headline of this white paper suggests, we are fundamentally capable of manipulating an ecological system to be something else almost entirely different. Almost entirely different. However, there is a trade-off and a balance in understanding what plants, as Peter will talk about, what plants can tell us about the environment and how it's changing, as well as simultaneously how effectively they can in fact do the job we're asking them to do. Of course, when we think about the plant at the scale of the plant, it seems there's almost nothing it can't do, right? The root growth and shoot growth, the response to an environmental condition such as this is really striking when you draw it in its totality and form. And so when we think about someone like Peter Del Tredici and being able to introduce this, I picked this photo not to embarrass Peter. I look up to Peter and I've learned so much from him. But because this, to me, says a lot about how we can view plants through this dialogue, through a relationship in which manipulation, in this case, yes, this is bonsai, so this is extremely scaled down, but when left alone to its own devices, as I understand, would and could be a totally different form and scale. And so the vision to see this, but also to enter into a dialogue about how it wants to be manipulated and what it can yield, is something that we look to Peter tonight for great learning. And the other element of this, which I think is so important and interesting, is the question of a shrubland. We talk a lot about grasslands and meadows, and many of you who have been in my classes know my obsession with them. And we talk a lot about forests and trees. However, we oftentimes skip over a fundamentally important and missing ecological system that comes to bear, in my mind, not only on the topic tonight of a living fence, but also on something even greater, which is the timeline and cycles in which manipulation of plants can be registered at a human scale. And I think that while we shouldn't necessarily always shift ourselves to an ecological process or design method that privileges our joy, feedback loops are vital, right? Feedback loops are vital. And so being able to manipulate plants, woody plants, both trees, shrubs, and grasses, but in this case, shrubs are the focus tonight, that can actually talk to us in relatively real time and give us feedback on what we're doing, how things are changing, and they can perform over the course of seasons, exposes a whole world of opportunity that I think is underbaked in our profession, and I think underbaked in many of the topics for tonight. And so Ethan, being an expert in his own right, both in plants and a knowledge of shrublands, was invited here to talk about these things. So I'll go quickly through this part because Ethan's going to cover more of this in depth and in greater capacity than I can. But I highlighted a couple important things here. Why aren't shrublands popular? Maybe because people like me talk about them. But also, yeah, I'm also not funny, I know. Maybe because people like me talk about them, but also because I think these two things are extremely revealing, and Ethan will talk about more of them. Because they are hard to access, they are hard to understand, and they do not exhibit many of the characteristics that we enjoy in the landscapes that we experience and go through. They are difficult, therefore, to imagine how to use, so to speak. They're hard to commodify. We think about Rosetta's quote. They're hard to ascertain, in a sense. And the other part of it, which I'm always fascinated with, and given the other hat I wear is around mapping and remote sensing and large-scale stuff, is that it turns out before the day we live in the 1970s and 80s and 90s, the technology did not really allow us to map them effectively. Aerial photography and some of the early methods we used didn't register them. So therefore, to a certain degree, when we drew maps of landscapes where we categorized different systems, they just didn't exist, even though we know for a fact that they were very much there and in abundance. But I also want to think about how diverse they are, from the saltiest coastlines to the highest mountain peaks across, especially Virginia, and in all the way through the Northeast, they exist. Not in large scale. I'm not suggesting that we were once and should be again conservationists associated with shrubbing everything, but rather that there's an immense genetic capacity and a plasticity Peter will speak about that is an opportunity to think about them with design in mind. And that the habitat that they can form, even at the smallest of scales, is a fundamental opportunity to consider their value in a different light. And so with that in mind, and having Ethan think through ways in which we think about design, being a practitioner, I should say, in a landscape architecture firm, our eye goes towards rather, or beyond ecological reporting and observational science to what do we do with these things and how do we manipulate them? So the last two images here were of R. denarii gigantea with a giant cane. And the final images we'll close with before we talk a little bit about who Ethan is are drawings from some of our students, specifically of Rus aromatica. And when we think about the ideas of manipulation and growth and how these plants can take on a life of their own and create space, the studies that were produced during our students' work with us this semester as part of the Holland team, again, inspire me to introduce Ethan, a plants person of extraordinary capacity, practitioner at Larry Weaner and Associates, formerly a practitioner at Michael Van Valkenburg and Associates, where I got to know him. And in this image here, maybe the best way I can provide insight into his special capacity is that it was Ethan who, in this photo on the right, many years ago now, was able to see something that many people weren't, including the owner of this site, which is that under our feet was sand, whether the owner wanted it to be or not, right? Under our feet were dying out grasses that were incapable of living in an environment, right? As Peter will talk about, plants were telling us something, but no one wanted to listen. And so Ethan's ingenious approach to something like this was to say, rather than attempt to fight the tide, why don't we play with aesthetics and the role of aesthetics in plants to create a meadow different? It seems maybe so obvious, but I'm continually surprised in my career how many people resist the idea of using different plants for conditions that scream for them. And so in this case, planting beach grass as a meadow, and frankly never telling the client about it, don't tell Michael I said that, turned out to be a really wonderful opportunity and an insight that I think you'll see when you hear from Ethan tonight is something that he can shed and share more on. So with that in mind, where I'd like to start this evening is with a discussion at the heart of how plants tell us about their environment and how those feedback loops can enable us to be more creative. So Peter, if you'll come on up, and I'll ask you to also introduce yourself, but as Peter Del Tredici comes to the stage, Peter brings an immense wealth of knowledge. He is both an educator at MIT and Harvard, a long-standing researcher at the Arnold Arboretum. He has been medaled by the Queen of England. He is one of the finest plants people internationally today, and also has been a mentor and friend of mine for well over a decade. If you'll welcome to the stage Peter Del Tredici.
Well, thank you for that introduction, Michael. And I do want to say that the one thing that when I asked him, well, what should I talk about? He said, well, talk about plants. I said, and my students, they want to hear about plants. I said, okay, I can do that. This first slide does not need any introduction. You're all familiar with it, I'm sure, but you get some sense of, what's happening to the world that we live in. And disturbance is a major element of my talk, and how plants respond to disturbance. And specifically, I'm going to talk about what species have the ability to resprout following catastrophic damage. And what does that mean? And these are the plants, my premise is these are the plants that are predisposed to deal with damage. They know how to deal with it. And so I'm going to look at, the ecology as well as the morphology of this. So this is a common mulberry. Most people consider it a weedy species, planted in the 1820s when Americans thought they could compete with the Chinese for the production of silk. That didn't really work out. I don't think any silk was ever produced in North America, but we have several million mulberry trees as a legacy from this period of time, what's called Moromania in the United States, when people were just buying mulberry plants and planting them as a get-rich-quick scheme. Now, this is a little bit of morphology. When you look at sprouts, and this is actually, it may seem technical, but it's really important. So when you look at a tree, the collar, which is where the stem and the root come together, is a source of sprouting. And if you cut an oak tree down, you can see how the shoots coming up from the trunk. But sometimes those sprouts will come from below ground, in which case there's a burrow underground that you don't see. It's technically known as a lignotuber. And sometimes certain trees like Prunus virginiana, the chokecherry, will produce rhizomes from the stem, even when if there's been no damage to the stem, and you can tell that you can tell it's a rhizome because the shoots arise some distance from the main stem. But trees can also produce new shoots from the root system, in which case on the left you can see you get new shoots, but not necessarily new roots. But then on the right-hand side, the new shoots will actually produce their own root system. So this promotes regeneration. So this is one of the ways that trees, I'm a big believer in regeneration. Rejuvenation is the word I like to use. It means that when they produce a new root system. So Michael showed that picture of me working with a bonsai plant. That was a 200-year-old specimen imported from Japan in 1913. And the main thing when you work with bonsai, it's not pruning the top. It's every 4 or 5 years you take it out of the pot and you prune away at least 30 to 50% of the root system, and you put it back in the same pot with new soil. And that forces the plant to form a whole new root system. And that's why that tree is still, they can live forever when you do this, because you're constantly rejuvenating that root system. If you left it alone, the roots would just go around in circles. They would eventually strangle itself and it would die. It would not be 200 years old. So the ability to form a new root system is critical to the rejuvenation of a damaged plant. And then the last one, the stem can also be part of this rejuvenation process. If an old specimen, the branch, through the effects of gravity, bends down, touches the soil, it takes root and can form a whole new module. This is, I'd start with a couple of these technical slides. Sprouting is a strategy that works well for a variety of environmental stresses and disturbances, including fire, browsing, and grazing. This is what you see all over Europe. You see plants sprouting because of the history of working with livestock, logging, beavers, flooding, drought, erosion, landslides, pests and pathogens, ice and snowstorms, hurricanes, and tornadoes. So this ability to sprout is a trait that almost all trees have the capacity to do it. Now, some will keep that capacity to late in life. Other trees sort of lose it when they get younger. So for tree seedlings, it's really important that they be able to sprout, because some animal comes along and takes a bite, and if it can't sprout back, that's the end of it. And a tree line at high elevations, where you have intense wind and snow conditions, the plants are often, growing very low. They what's called a krummholz. They're only about 3 or 4 feet tall under the sunlight, but where those branches touch the ground, they root. And so this ability to form a new root system, to layer, essentially, allows the trees to survive in these really stressful conditions. So you really need to look at the context in which the plant is growing in order to understand what's going on with that plant. Now, some examples. I'm originally from California. This is a California species. It's not one you have, but this is the California bay laurel following a fire in Santa Rosa, and you can see that generation of stems burned down. And that was probably from another fire, another 25 years earlier. So this is probably the 3rd fire that it's experienced at that time. It's an amazingly resilient species that, because it's from California, you can probably say it's a fire adaptation. And this is the way it looks. The tree was cut down, it was damaged, and you can see how it's just sprouting. Now normally that would be underground, but because of the conditions, growing, in an urban condition, that underground stem is exposed, brought up to the surface, and you can see the capacity for sprouting is immense. And there it is on the side of a steep slope, and that's the lignotuber that is the source of it. And that lignotuber is really part of the stem, so it's not a root sprout or anything like that. It's part of the stem, and there's a number of species that produce these, but not that many have specialized lignotubers. Root suckers, this is sweet gum, liquid ambar sterasa flua, and you can see how there's the mother trunk in the back on the left-hand side, and then those are the root suckers. So the whole plant is called a genet, and each individual stem is called a ramette. And what's really interesting, if you look at what's called the proximal end of each one of those new shoots, that means closest to its point of origin. The root is still the same diameter it was when the shoot was formed, but at the distal end, going away from the point of origin, it's much thicker. So you could say, well, is this, if those are the daughters and the mothers in the back, are these being good daughters? Are they sending any of the resources that they produce back to the mother? The answer is no, because the root going back to the mother is still the same diameter it was when the root sucker was formed, whereas the root going the other direction is much bigger, indicating much more physiologically active. So morphology can tell us a lot. The biggest example, most famous example of a root suckering species is this clone of Peter Del Tredici in Utah, 14,000 years old. It got established right after the glaciers receded. 47,000 stems, all genetically unique, with a total mass of 6 million kilograms. So this is one plant. It's really, so this is what happens when you have, no restraints on your ability to spread. And not too far from there, a similar species, Populus angustifolia, the narrow-leaf cottonwood growing along the sides of this Shoshone River, and you can see how the ability to sprout is really important to the survival of that species in this highly disturbed landscape. So the ability to sucker from the roots is a really important attribute of plants that grow in environments that are exposed to a lot of disturbance. This is a picture of a plant you're all familiar with, Robinia pseudoacacia, taken in Connecticut, and you can see there's the original planting of 6 beautiful Robinias that are probably, at least 60 or 70 years old, if not more. And then right adjacent to it is a similar stand that had been cut down. You can see that root suckering response. And Robinia, if you don't realize this was a tree that beginning in the early 1800s, people started planting all over. It grows as far north as central Pennsylvania, but the wood is highly rot resistant, and when you cut it down, it sprouts back. So farmers were really happy with this plant because they use it for fence posts. So you could cut it and it would sprout back, and it was highly sustainable. And that, of course, is the reason it was planted in Europe and in Asia. This is now considered, a highly invasive species worldwide, but it was originally very useful, and in fact still is useful, because when they build playgrounds now, they don't want to use pressure-treated lumber, they build them out of black locust. And black locust is now the organic pressure treated. So now the market for black locust has increased dramatically. You can't buy it anymore because the demand for it is so high. So things change, and what is considered I call it America's gift to the world, but some people still consider it invasive. And I'm on the Invasive Species Council for Massachusetts, and they made a decision to ban, once they classified it invasive, ban the sale of it. Even though it was native to central Pennsylvania, it was on the way to Massachusetts when the Pilgrims landed, so therefore it wasn't native. But people started planting it in 1800. So what's the point of banning a plant that is everywhere, just because it wasn't there when the Pilgrims landed? But and it ignores the fact that this was a very useful plant. And this is another little example, another plant that I'm fond of, the pawpaw, Azamina. This is at the Arnold Arboretum, planted in 1993. Same plant in 2003. You can see it's forming a multiple stem. There it is in 2009, starting to root sucker. Same plant, and there it is last year, 2024. You can still see the original stem and sort of in the back on the left-hand side. But this is that clonal growth. So species that behave this way, particularly trees, have, they're really very, very useful because they, they just, have this ability, if they're in the right type of environment, to really spread and to stabilize the environment. Another famous root-suckering tree, the tree of heaven, I assume most of you are familiar with this, was a major street tree in the early 1800s. You don't see big trees like this very often anymore. Most people have cut it down because they don't like the tree. But if you leave it alone, it's actually quite a beautiful tree. If you cut it down, this is what you get. And those are root suckers. And you see wherever you have different types of paving material coming together, there's a crack there where the wall meets the blacktop. And that's just perfect for the root. That's where water collects. So the roots grow there. And then when you cut the main trunk down, that releases all of those root suckers. And this is what you get. Those are not seedlings. Those are root suckers. And they really give you a sense of just how amazingly tough the ailanthus tree is. And I took this picture in Boston Harbor. You can see that's what a clone of ailanthus looks like that washed down into the ocean. It is one tough plant, and you never get to see the whole thing exposed like this. So this is the essence of what allows resilience in trees, allows them to be able to survive all sorts of catastrophes. If you know what you're looking for, you can begin to see this. This is the bur oak, a shrub. Bare oak, there's a little typo there, sorry about that. It grows on Cape Cod in very sandy soils, and because it's so dry there, they do have a fair amount of fires there, and you can see there's a mature tree, and following the fire, then those trees are dead, but the suckers are coming up like crazy following that fire. So you do find this is a fire-adapted species. And it works also for larger oaks. This is Quercus alba, again, following a fire. You see that sprouting there. And then on the right-hand side, that was a fire that probably occurred about 20 years earlier. And the original stem is gone, but those sprouts from the base are still carrying on. Silver maple, Acer saccharinum, sprouting in response to beaver damage along a river in Massachusetts. All of the silver maples looked like this in response to what the beavers had done. And river birch, which is an incredibly adaptable species. And on the right-hand side, and along that same river, the beavers are very fond of it, and the tree has this ability to recover from that. And this is the great American chestnut. On the left is a specimen. The chestnut hit Massachusetts in around 1920. So this is the way chestnuts used to be, a huge tree. And on the right, you can see it's producing shoots from the base. They're not root suckers, but it's still what they say smoldering at the roots. And there it is. These are American chestnut seedlings that I planted at the Harvard Forest when I worked there, and you can see how the original stem has died. Those new shoots are coming up, but they're producing their own roots. So this is that rejuvenation. So we still have American chestnut all throughout the forests of the Northeast, and those were seedlings that were killed by the blight in the 1920s and 30s, but they're still sprouting back. And so from an evolutionary point of view, the American chestnut is still with us. It's just on the way to becoming a shrub rather than a tree. And I love this Robert Frost line. It keeps smoldering at the roots, sending up new shoots. That really summarizes the behavior of that plant. And you can manipulate this, as people have done. This is a picture I took in England at Western Bird Arboretum. 600-year-old little leaf linden, Tilia cordata, a coppice. So it's been coppice for 600 years. And when you prune trees like that, that rejuvenates them because it causes them not only to produce new stems, but new roots. So essentially, they live much longer than if that was just a standalone tree because of the rejuvenation that occurs as a result of the continual pruning. And this is what the stem looks like after 600 years. So this is kind of amazing in my estimation. And then my own research, I've done a lot of work on ginkgo biloba over the years. This is the largest ginkgo in the world. In Guizhou province, 35 meters tall. The original stem is long gone, and what you have is this ring of secondary shoots, 4.5 meters in diameter, and it's thought to be about 4,000 years old. No way of proving that, but that is the estimate. And I want to contrast that with this work that I've done in South Carolina, Sumter, South Carolina. This is a 1,000-acre ginkgo farm. Plantation. They raise the plants for leaf production. It's a German company that runs this. And 10 million ginkgo trees, okay? The rows are a meter apart and the plants are 60 centimeters apart. And in the middle of the growing season, they run a modified cotton picker over it. They strip all the leaves off the tree, which they harvest and they use for, they dry them and then they send them to Europe for production. And then at the end of the growing season, on a 5-year cycle, they cut those plants back to the ground because they got to keep them small so they can harvest them by machine. And this is what they look like after 38 years of cultivation. So in other words, what they've done is they've turned these juvenile plants, these young plants, they have the same form as the ancient tree I showed you in China. So you can, and it's amazing that you can do that with seedlings. So ginkgo is the ultimate survivor. It can really, that's why it's still around. Its ability to resprout is one of the things that has preserved it so that we can still enjoy that tree today when all of its ancestors have gone extinct. And I mentioned layering. I don't know how many of you have seen the angel live oak on John's Island. It's a magnificent tree. And those branches, they take root. And once they take root, then the branch, the distal end of the branch becomes vertical. And it's just remarkable to see the clonal growth of the live oak. And then just to show you forsythia, I don't know if you love or hate forsythia, but if you leave it alone, once you abandon forsythia, it's going to take over. There is no doubt about it, and all through layering. So this is one of the things that shrubs are really good at, is this layering. So trees do it too, but not to the extent that shrubs are able to do that. And this is, I've never seen this before, this is on Cape Cod, red oak, Quercus rubra, where that branch got sort of bent down, I'm not sure why, but where the tip of it rooted, I went over there, I tried to pull it up, it was very well rooted, and, so even something like a red oak, a main trunk is able to root under the right conditions. And it's the fact that that's sandy soil, I don't think this would have happened in heavier clay soil. It's really an attribute of the fact that you've got good oxygenation there, which allows those roots to get established. And I'm going to talk a little bit about coastal environments. Salt spray rose, Rosa rugosa, a Japanese species introduced by von Siebold into Europe in the 1840s and then brought to North America. And this is after Hurricane Sandy. You can see the bayberry there in front of it has died completely, but the Rosa rugosa came back with a vengeance. It was very funny when I was on the Invasive Species Council of Massachusetts, somebody came in from the Department of Environment and said, no matter what you do, please don't put Rosa rugosa on the invasive species list. We need that plant. And there's nothing else that we can grow that will do as good a job of stabilizing the landscape as Rosa rugosa. So we dutifully did exactly. Even though the evidence suggested that it wasn't behaved as an invasive species, we did not put it on the list because of that request. And this is what Rosa rugosa does. It sprouts from every part of it that's left behind, the root suckers, the layered branches. It just comes back after everything. It's one of the toughest behind the, in the dunes, just behind the high water mark. And of course, the native species, the Virginia rose, grows in the same environment, but it's not nearly as tough as Rosa rugosa. And that's what the guy from the Environmental Protection Agency was saying, that we love the Virginia rose, but it's just can't do the same thing that Rosa multiflora does. And this is the same environment in Rhode Island, that bayberry, Morella pennsylvanica, sprouting after Hurricane Sandy. But some of the plants died back, but some of them sprouted. And then as we got closer to the shore, all of the bayberries died because Hurricane Sandy dumped a foot of sand on it. And that was just too much for the bayberry to tolerate. So the species really vary in their ability to deal with this, and that's where spending more time outside, just observing what's going on, should really inform the decisions that you make. I never would have predicted this, but if it's too close to the shoreline, the bayberry isn't probably going to survive a big storm like Sandy. And then that same, a little bit away from it, I want to take this. This is nice because you see the groundsel bush, Baccharis helimifolia. It's amazingly salt tolerant, grows all the way up and down the East Coast. This is just a wonderful shrub that is super tolerant. And I want to call your attention to that, what'd you call it? It's not a dune, but a hummock behind it, a sand hummock. So I had to go out there and see what was happening. We had to wade through the little bit of soil to a little bit of water to get out there. And this is what we found. Growing on it was an American linden, Tilia americana, growing, just behind that on the dunes. And look at the form of that American linden. You think of that as a huge tree, but it's suckering like crazy. And surrounding it is a thicket of sassafras stems. And it's not just random that these are the two species that you see there. This is what Tilia americana looks like when it grows along disturbed, highly disturbed riverbanks. It's multiple stemmed like this. This is the plant's response to disturbance. And if you see it on the streets, this is what it looks like. It has these little skirt around it of all these stems. And that comes on the right-hand side from this lignotuber that's normally underground, but because the soil is so compacted, it rises up to the surface. And those sprouts are a form of its insurance policy. So when the tree is damaged, they will sprout back. So everybody, when I worked on the plant hotline at the Arnold Arboretum, people would always call them and say, is there anything I can do to get rid of those sprouts? No, the answer is that's the plant's insurance policy. This is what makes the plant resilient. And it comes, this is an American species, but European species, that's what this is. Grows in mountainous areas, and that lignotuber is a way of sprouting back following disturbance from landslides or whatnot. And sassafras is a root-suckering species. So that's why those two species, you find those on that hummock just behind the shore. It's not just random that they're there because they can tolerate the disturbance that environment experiences on a regular basis. And on the subject of shrubs, this is, winterberry holly, one of my favorite shrubs, planted in 1892, but no stem there is more than about 10 years old. So the whole plant is, 150 years old. But no stem, and this is the thing, that shrubs rejuvenate themselves by constantly producing new stems, and they just get bigger and bigger over time. So that growth model is highly resilient. Sumac, you mentioned sumac. Earlier, this is at Boston Harbor, and sumacs are just really, really great. And one of the things I did at the Arnold Arboretum, we didn't have a sumac collection, but I built in this area where nothing would grow. I put our sumac collection there. And what's really interesting is that when you manage it, I told the grounds crew members in charge that, cut it down to the ground every 5 years and rejuvenate it. Yeah, it'll get up to be about 30 feet tall if you leave it alone. But we don't want sumac to be 30 feet tall. We want it to spread. And so disturbance is really what leads to this clonal spread over time. So learning how to manage this is, part of the deal. And this is gray dogwood, one of my favorite shrubs, another root-suckering species along an abandoned roadway. But this is the picture I love. We planted this in 1873 and cut it down to the ground every 5 or 10 years since then. So that was cut down in 2006, and there it is in 2011. So for, again, 150 years, we've been managing this hedge at the Arnold Arboretum. We never let it get more than about 3 feet tall. And this is amazing that the plant is still alive and well. And so this is one of the things that makes shrubs really interesting and great to work with, is their ability to sprout back following catastrophe. And speaking of hedgerows, I had to put something in about hedgerows. This is your classic English hedgerow, mostly beech trees, I think. And they have a whole system of laying hedges, they call it. And they'll cut the tree not all the way, just bend it over so it's still attached to the root system, and then it sprouts out. And once those take root, then they cut the original stem off. And they just keep doing this. They just rejuvenate it through this laying process. It's really remarkable to see how they do it. And this is a real science in Britain. We don't do it here the way they do it there, but they have mastered the art of laying hedges in England. And then this is an urban hedgerow in Boston. Those are green ash, and in the absence of maintenance, you get this amazing hedgerow. There's more wildlife in that hedge than you can imagine. And it's there only by virtue of nobody doing anything. And, I like to say, if you want to do something for plants, if you really want to help plants, just put in a chain link fence, because it's a safe site for them, because the maintenance people cannot get to them. And then this is what you get. After about 10 years. It's really remarkable. So this is interesting. And then hedges, of course, once they get established, seedlings of all sorts of plants begin germinating underneath them. So these become sites where, ecology really happens, because the hedges protect these plants from all sorts of bad things. And Michael mentioned Maclura. I love this. This is a picture. This is a mile-long hedge at Winterthur in Delaware. I don't know how many of you have seen this. It was planted, I think, in the 1920s, and they've been maintaining it ever since. And there's a Maclura. This is somewhere not too far from here in the University of Virginia campus. You may recognize that tree. I'm not sure where it is, but that's what Maclura does if you leave it alone, which is really remarkable. It's an amazing tree. But when it was first discovered, there's a couple at Monticello. I mean, Jefferson was one of the first people to get a Maclura from the Lewis and Clark expedition. But one of the uses they put it to immediately was using it as a hedge. And there you see the mile-long hedge at Winterthur. And the Siberian elm, not my favorite plant, but this is the hedge, row they use that Michael showed us, going from, the Canadian border all the way down to the Mexican border. This is about the only tree that is invasive in all of the Midwest, because trees don't grow in the Midwest, really. But this species, which is from Siberia, is just amazingly tough. I mean, the fact that it grows in North Dakota, that should tell you everything you need to know about it. And this is, the remnants of an old hedgerow. This is a common hedgerow species. And I hate this. People really hate this plant. And I was just in Colorado, and nobody had anything good to say about it. But the fact that it survives, that you don't have to say anything good or bad about it. It's amazing that it can without irrigation. There are no other trees that can grow, in the lowlands of Colorado as you get closer to the desert and survive. So this is the only woody invasive in large parts of Colorado. It's amazing to see it. And this is what happens. This is what the stem, when you go in there and you look at it, its ability to sprout back is one of the reasons it can survive. That's what makes it so resilient. So this ability to sprout is critical for plants being able to survive in stressful environments. And I wanted to end with a few pictures of grasses because that's part of the deal. The beach grass, I love this picture because all of a sudden you can see, you could create a mathematical model of how this this grass grows and spreads and predict over time what it's going to do. It's just an amazing species. And it's got these amazing rhizomes that spread. They're very sharp pointed. And I sent Michael an article showing that what these do, these rhizomes have the ability, if they come across a nest of turtle eggs, the rhizomes will penetrate the turtle egg and suck all of the nutrients out of the turtle's eggs. Now, this is not a genetic characteristic. This is adaptive. In other words, it's searching for nutrients and water, and it comes across an egg. It's a nice sharp rhizome. It penetrates the leathery shell of the turtle egg and then sucks all the food. It turns out in some locations, this is an important source of nutrition for this plant. So, when you get into these stressful environments, your ability to adapt and to deal with those conditions is really important. And a lot of it is not genetic. It's just simply an adaptive response. So sprouting is an adaptive response. I showed you trees that, don't sprout, but under the right conditions, they will sprout. So that's what was called an epigenetic trait. And there's a good planting of Ammophila in Boston Harbor. It really does well. And then there's smooth cordgrass, Sporobolus, growing on Cape Cod, the lowlands, and this is what it looks like. It's just an amazing plant. And then I wanted to end with this picture. I don't know how many of you are familiar with the New Jersey Turnpike, but I made my wife stop the car on this bridge. You're not supposed to do that. So I get out, took the picture, and you could look at that picture, you could say, well, oh my God, the Phragmites, this is the European subspecies, has taken over this, New Jersey meadowlands. But you could also say that there's over 400 landfills in here that are leaking nitrogen and phosphorus. And this plant, which is used for tertiary water treatment across the world, is actually helping to clean up this mess that we've made of the New Jersey meadowlands. And it's doing it at no cost to the taxpayer. So, tell me again what the problem is. If this is what used to be there. Salt meadow cordgrass used to be known as Spartina patens. So what I like to say is, if you wanted to get rid of the Phragmites, it would be relatively easy and straightforward and bring back the salt meadow cordgrass. All you have to do is you just remove the New Jersey Turnpike. Because that meadow used to be tidal, and that flushing of that whole area with tidal kept the salt level high enough that the Phragmites it was too salty for Phragmites. And but what the New Jersey Turnpike was a barrier. It prevented that from happening, and that's when the Phragmites got established, because it became brackish after they built the New Jersey Turnpike. So it's really important understanding what's going on with this. And I think that is here's my last slide. Just to show you how adaptable Phragmites is and why everybody hates it so much. On the left-hand side is Detroit, and there's no water here at all. And that Phragmites that's growing along that fence line, that of course is the safe site there, it went under the sidewalk and came up in the gutter there, which is kind of remarkable. And then on the right is the Fresh Kills landfill, and that's nothing but stone. And there's the Phragmites growing right at the edge where there's a concrete bunker there where a little bit of water collects. And then it sent up these rhizomes. They were 5 meters long when I measured them. And that is just an amazing, you want to know why Phragmites is spreading everywhere? This is why. It can grow under any conditions, and it can take advantage of them by vegetatively reproducing. So with that, that's my last slide, and thank you very much.
Thank you very much, Peter. So to follow up with that, I'd like to invite Ethan Dropkin to come up and speak on shrublands as a solution. Ethan, again, as I mentioned before, as a practitioner at Larry Weaner Associates, spent time with New York City Parks. Before that, with myself at Michael Van Valkenburg Associates. You can also catch Ethan and his incredible plant knowledge, generational plant knowledge, on Plant Talk, correct? You've spoken on Plant Talk before?
I don't know. I've spoken a lot of places. Yeah.
Maybe not Plant Talk. Okay, then I've got that wrong.
Yeah, so I'm going to talk about shrublands as a solution to some of our landscape issues, but also about shrublands as a system. So we talked a lot about woody plants generally, but just I like to kind of start at the most basic level always. So what is a shrubland? And essentially, it's very simple. It is a landscape where shrubs are the dominant vegetative cover. And they have a lot of common names: thickets, scrub, scrubland, brush and brushland, and then heaths, which that's a very particular type of shrubland where it's usually under 4 feet tall and it's dominated by plants in Ericaceae. So heaths and heathers in Europe, and in North America, vacciniums, blueberries, and Galesacias, huckleberries, things like that. Trees are often part of a shrubland, but generally are not the dominant part, because then it turns into a forest. And also herbaceous material is almost always part of a shrubland matrix, either as kind of an underlayment to the shrubs, or where you get these patchy assemblages where there's kind of clonal masses of shrubs and then a run of herbaceous material, and then the shrubs pick back up again. Globally, there are parts of the world, particularly more xeric environments, especially in Mediterranean regions around the world, where shrublands are the dominant cover type, where, you know, as succession occurs, it ends at shrublands. It doesn't continue on to forest. And there's all different kinds. A lot of them have very cool regional names. So this bottom left image, that's the fynbos in South Africa. That's sort of this coastal shrubland along the Cape. There's also thorn scrub in Texas down into Mexico, the Caatinga in South America. The bottom right picture, that's the coastal chaparral in California. The maquis, which is the Mediterranean shrublands. And then my favorite one, just because the name is so cool, the quangin, which is in the Mediterranean parts of Australia. And these are areas where the climate patterns don't support trees. It's kind of, because of how climate systems work, shrublands are the things, that's what it stabilizes as. In the East, shrublands are not our dominant cover type. Forests tend to be the dominant cover type. But we do have usually small areas of stable shrublands. And these generally happen on either pavement barrens or outcrop heaths, you know, up at the top of mountains, mountain ridges. Dunelands, often in pine barrens you'll have shrublands, but basically where the soil is really sandy. And then at the other end of the spectrum, shrub swamps and bogs. Bogs are often, you know, very low shrubs, but shrub dominated. And these are areas where either the soil is too dry or too thin profiled to support trees, or too wet, or too kind of, there's too much water fluctuation in them for trees to grow, but shrubs are able to handle it. So those are naturally occurring shrublands. In the East, though, because of the sort of massive amount of disturbance that we have done and continue to do constantly all the time, often we get shrublands as kind of either part of a continuum of succession or kind of in arrested development. So usually old fields kind of progress to shrublands and sometimes stabilize as them for periods of time. Also, we get a lot of kind of woodland edges where you have sort of a shrubland buffer. Often these are invasive dominated in the East because a lot of times that's what goes along with disturbance as invasive species. But there are plenty of native shrubs that are also able to capitalize on these kind of disturbance continuums. And I want to talk quickly, thinking about that sort of disturbance and how succession occurs. Frank Egler worked at Connecticut College in the 50s and came up with this idea of the initial floristic composition hypothesis. And that was from the work that he did in Eton Forest. This is a picture of that land. I think it was his family farm that then he turned into kind of this amazing ecological research laboratory. And essentially, the idea is that all of the plants that are going to occur as part of the successional process are there at the outset of that successional process. That kind of the idea is there's not quite as much deposition as is often thought of sort of over the course of succession, and that really the trees that are going to be there at the end of the process are there at the very beginning. The shrubs that are there at the very beginning when it's just appears to be herbaceous dominated. And then building off of that, Nearing and Goodwin, who also were working at Connecticut College, in 1974 published The Creation of Relatively Stable Shrublands with Herbicides, Arresting Succession on Right-of-Way and Pasture Land. And so what they did was, through active coming at it from this idea of initial floristic composition, they explored that and essentially actively managed trees out of a shrubland complex. And what they wound up with were closed canopy clonal shrublands that were incredibly suppressive to any other growth and didn't allow for weedy growth to move in, specifically for it to kind of transition to forest, which is most likely what would normally happen in Connecticut. But because they managed the trees out of the initial flush, they wound up with this stable shrubland. And the stability, I think some of the shrublands that they had in that study lasted for 15 years or longer without getting any invasion by trees. So that just goes to show that a managed shrubland, if you're able to kind of get in early, take trees out of the equation, even in the East, we can create these sort of closed canopy, mainly clonal shrublands that are incredibly suppressive to other growth and are something that we can kind of think about as designers as a tool that sort of by managing out the trees and relying on shrubs, then we get this thing that is suppressive to weed growth, which is often something that is really important. We have, we're constantly trying to think of what's a low maintenance landscape. Clonal shrublands are some of the most low maintenance because of this stability that they provide. So in 2012, NRCS published Conservation Practices Benefit Shrubland Birds in New England. And this kind of touches on what Michael was talking about, which is shrublands generally in the East have been overlooked, undervalued, and not seen as something that is part of kind of the complex assemblage of habitats that we have, or not valued as an important part of it. But this research found that there were 41 different bird species in New England that their preferential habitat for breeding was shrubland, and that, in fact, incorrectly, the assumption had been, oh, these are woodland edge species, because there was very little shrubland and lots of woodland edge. But once they were managing the landscape specifically for shrubland, they found that the birds were preferentially choosing that shrubland rather than woodland edge habitat to do their breeding. And so it just goes to show that even though this is kind of this undervalued cover type in New England, it's really, really important. it also, another thing, and this I found particularly interesting, is that different bird species were using different densities of shrub and different heights of shrubs. So not only was shrubland an important habitat and cover type, but a diversity of different types of shrubland was more important than just, okay, we have kind of one clonal mass, everything's the same age, it's all kind of the same density. That was less valuable than a bunch of different ages, a bunch of different densities, all kind of sharing this complex patchwork. Also, shrublands are at an 80-year low in New England, and shrubland birds are in particular decline because shrublands are sort of at a premium, and partially because forestry growth has really been kind of the letter of the day of this is how we treat landscape. This is what wild landscape should be, is forest. But really, these shrublands have a lot of value, particularly, so this bird is the golden-winged warbler, which in New England and New York and New Jersey, where I live, some of the only places that this bird that is in its populations are crashing. And part of that is because it goes in this insane migration, and you know its habitat in South and Central America is also under threat. But in the East, there's just not that much shrubland habitat, which is what it needs to breed. And power line cuts like this are some of the most high quality habitat that it has left because they get managed as these stable shrublands. So yeah, they're really important, they're really fascinating, and they're really valuable in a way that has really been undervalued. Okay, so let's talk about, and you know, I don't want to totally retread what Peter was talking about, but generally when we're talking about a shrubland matrix, shrubs really occur in two different forms. There's clumping ones, which sort of have a main clump of stems and maybe march out from the center slowly over time, but they aren't sort of spreading and filling in the way that clonal shrubs do. So they spread through, we heard about rhizomes and stolons and all different ways that they spread. Clumping shrubs tend not to produce thickets on their own, although they can if there's a lot of them. But both of them can form shrublands, and often they'll form them in concert with one another, where you'll have a mix of clumping and clonal shrubs making up the shrubland. And then from a design standpoint, they also can be interplanted to support one another in design work. So this is highbush blueberry, which is a clumping shrub. It tends to get quite tall. Very beautiful architectural kind of orange bark stems, and of course we all love blueberries as a fruit, but it's a great kind of architectural plant in a purely aesthetic landscape as well. And so this one was underplanted with Rosa virginiana, which Peter was talking about, and what the rose did is it's much shorter than the blueberry, and so it basically filled in, it was the ground layer in this blueberry bed, very suppressive to weed growth. So it was this very, very low maintenance, very beautiful, dynamic planting that was just two native shrubs, one that's clumping, that's giving you the real architectural thing and spectacular fall color and edible fruits and early white flowers, and then this low clonal plant that's growing in between that is providing weed suppression, flowering at a different time, different fall color, different fruits that serve a different purpose, but they work in concert with one another to create this very stable but also very aesthetic landscape. Another thing to think about with clonal shrubs is, so Peter was talking about how successful they are and how readily they spread and how this is so important for them and their function. Sometimes for landscape architects, though, that can be problematic. We love clonal shrubs, but we don't necessarily want them taking over all of our landscapes. So this is a mass of gray dogwood at the edge of this huge meadow in Lakeville, Connecticut. And how it was managed was there were sort of small clusters of these in the meadow, and we mowed around them. And so originally this was shrubs with herbaceous vegetation around it, and over time those shrubs spread to fill that island and created this clonal shrub mass, but the mowing around it arrested the spread and the growth. It didn't stop it altogether. Occasionally stems will kind of pop up beyond or even in the path, But the mowing is generally enough to kind of keep it contained to the point that it's not going to take over your entire meadow, which you don't necessarily always want turning into a shrubland. So thinking about clonal shrubs, you want to make sure that you have planned in a way to arrest their spread, whether it's mowing, whether it's, you're planting it in a concrete planter and it can only go as far as it can go, whether there's some sort of root barrier, or whether you're using it at a place where you don't care how far it spreads. You want it to spread and fill. You want it to cover. You want it to create the shrubland. But it's not insignificant, and you definitely have to think about it when you're trying to use these clonal shrubs in landscapes, especially up against something like a meadow, which could easily turn to a shrubland without management. So this is an interesting concept that I don't have a lot of scientific data to back this up, but this is something that certainly there's a lot of observational data to back it up. And I think this is sort of worth research, and I'm hoping that people start thinking about this. But one thing that we have found in our practice, and something that I have talked to nurserymen about and they've reported back to us, is that these clonal shrubs, when you propagate them from their vegetative growth, can often either have a suppressed clonal nature or lose it altogether and become a clumping shrub. Even something like gray dogwood, which is sort of like, or like this Ilex glabra, strongly clonal plant. But I really encourage you to kind of think about, when you see this plant out in a landscape setting, does it have that skirt of suckers? Is it sending out things everywhere? Or is there maybe kind of one or two little sprouts down below it, and mostly it's just a big, clumping shrub now? Sometimes what that can have to do with is that the soil, you put a runner in heavy soils, it's not going to run as hard. But it does seem like there is some correlation between propagating these clonal plants from vegetative scions and them not having quite the same robustness of clonal ability as adults. And why this is significant is that if you're trying to use these as tools in your landscape, you're like, okay, I want to plant these shrubs, I want them to spread clonally, and then you put them in and they just clump. They don't do what you're wanting them to do. So yeah, that's Ilex glabra in a landscape, just a big clump. That shrub is probably 25 years old, and it hasn't spread to fill the whole bed that it's in. Whereas that's a wild population in sandy soils on a dam in the Pine Barrens, and that's all one plant that's just sort of spread along that whole artificial ridgeline. So how do we get around this? How do we sort of leverage our ability to kind of still use these plants and get them to do what we want? One of the ways that we've been using them is we'll still get like a 5-gallon Cornus racemosa and put it in, because we want something that's big, that has the height, that has the breadth to fill it, that looks like something right when it goes in and the client's happy. They're like, I paid that money and there's the shrub. But what we'll do is then get seed-grown whips and then plant them around the base of it and sort of fake how this plant grows in nature, where you put the little suckers that are going to retain that clonal ability because they're seed grown. And this is often how these plants grow. That sort of, there's an original parent plant that gets the biggest and then sends out all the babies around it. We saw the pictures. Peter had a bunch of examples of how plants grow that way. And so this is a way to kind of fake that and still get what you want and actually have that system working. The clonal nature is still going to happen, but you're sort of faking it at the beginning to get what you want. The one thing that is a consideration about this is that a lot of these plants aren't seed grown. Nurseries aren't generally seed growing plants. It takes a lot longer to get a saleable plant. So understanding where this nursery stock is coming from and where you can get seed grown plants and how to be able to use those is really important to be able to successfully use these plants the way you want to be able to. Okay, so let's think about now using woodies as living fencing. And we've touched on this a little bit. So first of all, it has a very long history. The use of hedges to demarcate field boundaries goes back to the Bronze Age, at least. that bottom left picture, that's a hedge in Cornwall that's been there for 4,000 or 5,000 years, as far as they can tell. And hedges as living fences have historic and current use across the world. In Europe, in India and Southeast Asia, in South and East Africa, and in Central America. These are all places where they use living plants to create boundaries and hedgerows and fences. Now, the species that are often used as part of these hedgerows, particularly when we're thinking about using them to contain livestock, tend to have three main characteristics. Sometimes they have all of them, sometimes they just have one or two of them. But generally they're thorny, because you want a plant that an animal is not going to feel super comfortable getting up close and personal with. That doesn't work with all animals. Goats tend to not really care about thorns and will just eat them. But sheep, don't love a thorn. You have to think about the animal you're using it on. Also plants that have very dense growth habit, that the plant itself kind of creates an impenetrable wall that is difficult to push through or knock over or step on top of. And then plants that are unpalatable or even poisonous. And then I was talking to Peter about this, and he was like, and the fourth one is they're plants that regenerate. They're plants that make more of themselves. And one thing that was interesting in the research that I was doing for this is, while all of that is true, particularly when you're talking about plants being used to contain livestock, often, as is the case in that bottom right picture, so that's euphorbia in Africa. So it's thorny, it's unpalatable to livestock, it's poisonous, they can't eat it, the latex sap will make them sick. It has a dense growth habit, it grows these kind of stems that all grow tight next to one another. But it still has some sort of man-made structural element that is a part of it. And this goes back to like the earliest example. So back to that 4,000 or 5,000 year old hedgerow in Cornwall, you can see it's shrubs, there's plants that are doing the work, but below that there's this kind of rocky earthen berm that they built to sort of start this idea of, okay, cows, like, don't leave this place. And then the plants grew up, and now they've, as Peter was saying, they've developed all kinds of amazing ways to actively kind of farm these woody materials to make them better and better and better at being fences and hedges. But it's interesting, it was very interesting for me to see that in so many of these examples, you'll have the plants and then you also have some sort of structural thing that is helping to hold the plants up, keep the plants in place, keep the animals out, which was significant. It was and something that's interesting, particularly if we're thinking about using these things to curtail the spread of livestock. So thinking about using native plants to the east as living fences, we want to use clonal species that are going to propagate more of themselves. We would like to try to use species that are thorny and dense and are unpalatable. And I think also thinking about ways to use multiple species in concert to sort of help one another if they don't have all the characteristics that we're talking about. There's a bunch of different potential plants for research. Crataegus, that genus, the hawthorns, is humongous. There's so many different species, and almost none of them are in commercial cultivation. There's basically one main cultivar of a species. It's Crataegus viridis winter king. That's the only one that you can get from nurseries. That's not entirely true. There are a few other ones. Crataegus phainopyrum is like occasionally available, although I feel like that sort of is seen as more of an old-fashioned plant. People don't grow it anymore. But there's so many species that have never been actively cultivated, some of which are even better in terms of their density and their form and their thorniness and all the things that we're talking about that could make them potentially useful for this purpose. And I'll mention, so that slide that Michael showed of that book from the 1800s with all the different ways to use the plants, wasn't it all of those were hawthorns? Yeah, that was all those things. They were all using hawthorns for those. Another plant that I think is underutilized in general, but could be particularly useful for this, is this plant right here, Prunus americana, which I also think stands for, as an example of all these native suckering shrubby plums that they're not available in cultivation generally. Nobody grows them. They are available in the wild. They're amazing for pollinators. They produce edible fruit for humans and for wildlife. They're dense, they're thorny, they're clonal. They sort of check all these boxes for us. And for some reason, just nobody's propagating them. So this, I think, is a really underutilized plant in general, but particularly for this idea of can we use it to create fences and hedgerows. Robinia hispida, this is one that kind of fell out of fashion, and I think it sort of like Robinia pseudoacacia, people got a little nervous about invasiveness as a concept with it, but it's clonal, it's thorny, it has great flowers. It's another one that I think could be really useful. It was very popular in the earlier part of the 20th century as a erosion control plant, to the point that like there are populations that I know in the Catskills that have been there probably since like the 50s, and the same plant, that same original plant that went in is still there suckering, making more of itself in what is arguably the wrong environment for it. It's way up in the Catskill Mountains, which it's not native to there, but it's chugging along, and I would argue it's not invasive. It's not, well, I don't know. This is always a thing, because it's like, you see, people are always like, well, it's not invasive in my garden, so I don't want to go down that route. But I haven't seen it spread beyond the original populations that was planted. That's not to say that couldn't happen. And then the Rus species. So that Rus typhina, Rus glabra, Rus aromatica, Rus copalinum. They have a good stem density, but that's another one that I think could be really good in concert with some thorny things. So like a clumping hawthorn and this clonal rus, and you plant them together to make this kind of complex system where they're doing this thing and working together with one another to create this living hedgerow. And there's a lot of potential benefits of them. So first of all, there's the potential reduction of non-renewable fencing material. We use a lot of metal, which is a non-renewable resource, to make fences. If there was a way to use less of it in concert with this, or to use this with wood instead, that could be really helpful. Also, you have the potential to create these kind of native habitat belts as part of our farming systems, which in the UK, the hedgerows there are so important. They're these massively important ecological drivers that are, refugia for rare and endangered species, and are supporting a whole host of plants and animals and insects. And we can do that. There's no reason, nothing stopping us. But it means that our productive landscapes are not just productive for us, but they're productive as these kind of ecological frameworks, which I think is what a lot of us are interested in seeing happen more. It also has the ability to have multi-cropping as a part of it. So, this plant produces edible plums. That could potentially be a secondary resource for a farmer that they're raising their sheep, and they also can sell these plums at a farmer's market that, people are going to be excited about eating native plums or native plum preserves or whatever it is. So there's the potential to kind of have sort of layered resources provided by this thing that we are at least talking about in this case using as fencing. But additional research is needed to understand efficacy, improve the benefits, and see how to do this successfully in North America. There's so many examples around the world that I feel like it's not a far stretch, but we do, we are research-driven people. We want to understand how these things work, and so that definitely is needed. All right, if you fell asleep and you just woke up now, what do you need to know? First of all, managed shrublands are some of the most competition-limiting landscapes that exist, and specifically managed clonal shrublands. Shrublands are a unique habitat type that is in decline in the East, along with the species that rely on them. Clonal shrubs and clumping shrubs, some of them spread by themselves, some just sit in one place, and understanding the difference between those two is really important. And then living fences have a long history across the world. They've been used by countless cultures. They often incorporate non-living structures to improve efficacy when dealing with livestock, and they're worth exploring more widespread use in the East. So, we did it. Thank you.